what do you see as the utility of animal studies when applied to humans? Because very often we've got a lot of the natural anabolics or the natty muscle builder supplements use ingredients that have some interesting data either in plants or rats or some other kind of mammal, and we haven't seen a human study on things like lexogenin before or ecdysteroids. A lot of these plant compounds or something that's extracted from an insect's left hind wing or something like that. These little proteins, and we hear all these outrageous claims that it's going to significantly boost protein synthesis, and then you look at the studies and it grew a rat's left leg, the calf muscle in his left leg by X amount of percentage. What carryover, if any, does that have to humans?
In terms of translational research, it usually goes in vitro. So looking at something in a petri dish on either muscle fibers or stem cells. Mm-hmm. Then if it shows some promise, then in animals, and then finally in humans. So to actually translate from mice to humans, you first need to determine the dose at which there's no adverse effects. So what is that level of dose? Mm-hmm. Then you need to convert that no adverse effects dose to the human equivalent dose. So most doses in mice are about 30 times more on a milligram of supplement or pharmaceutical per kilogram of body weight or per unit of surface area compared to humans. Mm-hmm. So if you have to take 5 grams of creatine per day, 5 grams of creatine, let's say you have a 100 kilogram person, that's 0.5 gram. I'm not doing math correct. I haven't had enough coffee today. But you get the point. It's a huge difference in dose between animals and humans. So that's one thing to consider. Is that the animals are getting a much greater dose than people are per milligram per kilogram. The second thing to consider is that you can highly control what animals do. So you have mice in a lab, and you can control their wake, their sleep, their food intake, their activity, etc. You can also put them through some very intense training programs, whether it is a swimming program or oftentimes what we look at for hypertrophy is what's called surgical ablation. So you mentioned the calf, right? You have 2 muscles in your calf. You have the soleus and gastrocnemius,
right,
and plantaris as well. So oftentimes we will, or scientists, lab technicians, will remove the soleus and gastrocnemius. So only the plantaris, only that little muscle is available for plantar flexion, or to extend the calf, extend the ankle. And so you get some huge hypertrophy because that muscle has to do some serious compensation. Mm-hmm. So that's point number 2, is you have much greater control in animals than you do in humans. And then the final thing to consider is that mice, or really any smaller mammal, has an incredibly fast metabolic rate and a very short lifespan. So if 1 human year is 7 dog years worth of development and aging, then 1 human year is about 35 to 40 mice years worth of development and aging. So a 1-week study or a 2-week study, whatever, in mice might be equivalent to be about a year in humans. So when we look at these studies, we have, especially, for example, intermittent fasting and how effective it is in mice. 12 hours of fasting in mice is equivalent to 70 hours, so about 3 days of fasting in humans.
Okay,
so those are 3 things to consider.
Yeah.
I
was going to say, for all the hype that intermittent fasting is getting as a life extension tool and mental clarity and all of this other stuff, it's we need to take a pretty big pinch of salt with it when they keep talking about all the animal studies that they're referencing.
Yeah. If you want to, to translate it to humans, then you need to fast for like 3 days to a week to kind of replicate the same methods.
Yeah.
And so, because of these differences, it gives you an idea of potential, but it also creates the need for translation or testing in humans before you can say with any level of definity that this product is going to be effective or is not effective. And probably the best example of that is CLA, or conjugated linoleic acid.
Mm-hmm.
In that, in mice, there's a number of studies that shows it enhances body composition and decreases in body fat, but in humans it doesn't seem to do anything at all.
Correct. And same thing with raspberry ketones, green coffee bean extract, and all of the famous, I call them the Dr. Oz fat loss supplements.
Yep.